Hi, good evening, everybody. And I just sort of wanted to talk about some of the design patterns maybe you guys can also leverage or use in your day-to-day work. These are some of the stuff that ideally I have implemented or we have implemented in our company, right? So let's get started. So what we do is basically we try to make these generalized templates that we could use across all the process or projects. So for example, logging is something that is crucial for us, right? So what we do is we made a class called logger, and this has this has the logger instance, right? So anytime we inherit from the logging modules, we can easily use that. The logging module again has a Datadog class, so it's a composition, right? We create an instance, so anytime we log something we do see in the log files, but also that is also logged on the Datadog, right? So again, this becomes like a Python package. So now we have a Python package called logging modules where the user can now use the logger class, right? And they can essentially easily implement logging functionality, right? Some other things that we have done is the metadata class. So again, this is a metadata on DynamoDB. So whenever a jobs or any sort of a script runs, it will create a unique process, which is a GUID, and that process is essentially in the log file we have the process ID, right? And also we have the process ID in the DynamoDB. And throughout the process or throughout the journey, either the process is successful, failed, in progress, the state is maintained. So now I know how long a process took, right? And each process can have several tasks. If there are functions that you need to get more visibility into, you can simply decorate, and that would essentially create a task. So a process can have several tasks which you can essentially get into more visibility about a function. So you can see, oh, this took this much time, it started at this time, it ended at this time, and if anything fails, the error is captured, the task is marked as failed. So now I exactly know so I know the process in general that it failed, but I also know where exactly it failed because I have these tasks, right? So I can see, oh, and on task 2 essentially it failed, right? So capturing the metadata. So what we did is basically we made a module called metadata dynamo, and then essentially people, whenever they're writing jobs, they can simply import or inherit these functionality, right? And automatically logging, error handling, all that is taken care of, right? Similarly, for example, if you observe, we have an interface for database. People work a lot with database, right? We have Mongo, Aurora, again SQL Server. So a better way to do that is basically we made an interface or an abstract class here. These are methods. So any class that inherits the database interface, right? They all need to provide the implementation. For example, if you observe SQL Server, MongoDB, they all have the same naming convention: get data, insert many. So which means I have a standard naming convention across any class I further add into that. So think of database modules as type. These are like different types, right? And the way we access or the user can access these database is through a connector. Well, connector is essentially what we developed here is a enum. So here you have an alias, for example, QA SQL Server on-prem, QA Aurora, or prod Aurora, right? So basically the user can say connector.qa SQL Server on-prem .value, and when they use the word .value, automatically they have the instance of the class, which means now they have access to all these 4 methods: get data, execute, non-query, insert many, and get data batch, right? So get data batch, again, we don't want to return all the data, so we have made it in a way that it returns an iterator object, and essentially in simple terms it's a generator. So you need to iterate over that data, or the generator essentially. So what I'm showing you is basically a interface, and any class or any further class we had, they inherit from an interface. They have to provide an implementation, and each database has a setting, right? Has a relationship, right? So we create a instance and then we pass it on to this database, right? So for example, database scraper, database Aurora, SQL Server, they all have settings, right? These are general settings. These are essentially stored in an environment variable, right? So that's that. So if you observe, it's a pretty neat and clean design. So if you observe, again, we have modules for AWS. Again, this is one of the class that we have. We have a settings class where we define access, secret, and region. And then we essentially create the client or the Boto3 in the appropriate classes. We have an SQS, SNS, Event Bridge, all these classes that the user can use. So the goal is here to make these common modules and packages so that you guys can reuse it much more efficiently. Now, what we also try to do is basically, for example, these common modules like logging, Datadog. So we try to host them at essentially host in S3 because we don't want, of course, we don't want it to be exposed to public. So we essentially put it on S3, and what we do is we can essentially use the instance at runtime. So what happens is, at runtime we load the instance from the S3. So the logger class will be loaded at runtime from S3. Again, that is again a injection model, which we also follow it in the batch framework. So if you come here, and again, very, very quickly, if I had to show you, so. Okay, so if you observe, yeah, the same thing we opted out in the batch framework while designing this, right? So what happens is, if I just show you the architecture here. So whenever the job starts, right, the templates are stored on S3, and what happens is the cron will fire the Lambda will pull out the metadata from SQL, job details and all these other metadata. It's gonna pull and it's gonna pass to the environment. Then it's gonna create these are gonna essentially spin up Fargate Spot instances, and once it starts running, there's a template, right? These are gonna pull the templates from S3 at runtime, of course, business logic, logging, error handling, and then it does the job, right? So ideally, having design patterns, having common design patterns as well. For example, we don't write try catch everywhere, right? We essentially made a decorator. Basically, we just decorate the function or the class with the decorator, and automatically try catch is inherited. So anytime a function fails, it would return a status code as -1, and there is an error entity in which you will get the exact exception. So stuff like that. What you want to do is basically try to make it as generalized as possible. So for example, if you're calling an API, right? So maybe first of all, an abstract interface. For example, make HTTP get, make HTTP post or put, whatever that is, then inherit into a request class, and then make essentially, provide the implementation there, right? And since you have logging and stuff, now you can simply keep inheriting the module. So if you need logging, okay, inherit from logging class. If you need this, okay, inherit from this class. So basically, what you have done now is you have built all these templates, and now you could reuse the templates in your project based on the use. So what happens is, in the company, usually when you have all these Python classes template, that it becomes very easy for the developer. He doesn't have to go to Stack Overflow, error handling, all the logging, all the built-in stuff is taken care, right? So I hope this video was useful and you did find insight. If you have any more questions, let me know, and I will see you guys in the next video.